Dear students, in the last lecture we have seen probability distributions. In this lecture, with the help of Python, we solve some problems from probability distributions. The problem is taken from a book written by Ken Black. The title of the book is Applied Statistics. So, we will see the problems now. Okay, now I am importing a SciPy, importing NumPy as NP. From SciPy.stats import binom. Binom is for doing binomial operations. And one more thing, you can import picture also. For example, this picture, that is that empirical distribution picture I have taken from this source, that is exclamation symbol, square bracket, that link should be in square bracket, then you will, when you give that link, we can get that picture directly. Okay, I am executing this. Yes. Now we will see the problem. A survey found that 65% of all financial consumers were very satisfied with their primary financial institution. Suppose that 25 financial consumers are sampled, and if the survey result still hold the true today, what is the probability that exactly 90 are very satisfied with their primary financial institutions? By looking at the problem, we have to see what kind of distribution we are going to use. Here there are two possibilities, satisfied or not satisfied. So, there are two possibilities there. So, then we can go for binomial distributions. Okay, print binom.pmf probability mass function k equal to 19, that is we say in the probability distribution context x, n equal to number of sample, p is probability of success. Now, we can see that the answer is 0.09. So, there is an 0.09 is the probability that exactly 9 are satisfied with their primary financial institutions. We will go to the next problem. This book, problem also taken from that book. According to US Census Bureau, approximately 6% of all workers in Jackson, Mississippi are unemployed. In conducting a random telephone survey in Jackson, what is the probability of getting 2 or fewer unemployed workers in a sample of 20? Here we want to know 2 or less. So, the probability of 0 plus probability of 1 plus probability of 2. So, we have to do the cumulative density function. So, here for doing that one, you have to type binom.cdf 2, 20, 0.6. The 2 represents less than or equal to 2, 20 represents the sample, the p represents the probability. So, when you run this, you are getting cumulative probability of 88.5%. We will take another problem, solve the binomial probability n equal to 20, sample size is 20, p equal to 0.4, x equal to 10. So, binom.pmf, you will get the answer for 0.117. We will go to the next distribution, Poisson distribution. So, in the Poisson distribution, for doing Poisson distribution, you have to import the library Poisson distribution from scipy.stats, import Poisson. First, we will find out Poisson probability mass function. So, Poisson.pmf 3, 2, 3 represents the x, 2 represents the mean. We will see another problem. Suppose bank customers arrive randomly on a weekday afternoon at an average of 3.2 customers every 4 minutes. What is the probability of exactly 5 customers arriving in a 4-minute interval on a weekday afternoon? By looking at the problem, you say that we know that the arrival pattern follow Poisson distribution, and you have to be very careful on the unit of mean and the unit of x, both are in 4 minutes, then no problem. So, simply you can Poisson.pmf is 5, 5 is your x value, Poisson.pmf. So, 3.2 is the arrival rate. So, 5, 3.2, that is the 11.39%. We will see one more problem. Bank customers arrive randomly on weekday afternoon at an average of 3.2 customers every 4 minutes. What is the probability of having more than 7 customers in a 4-minute interval on a weekday afternoon? So, here we have to find out the probability of x greater than 7. Okay. So, what we will do? First we will find up to 7 with the help of this, that we will save in a object prob equal to Poisson.CDF 7 and lambda 3.2. So, when you subtract 1 minus of this one, then we will get probability of more than that. Yes. So, I am finding up to 7. When you subtract 1 minus that up to 7, you will get more than 7. Okay. We will see another problem on Poisson. A bank has an average random arrival rate of 3.2 customers every 4 minutes. What is the probability of getting exactly 10 customers during 8 minutes interval? Now, you should be very careful here. The unit of x and unit of lambda are different, because it is a 4 minutes, it is 8 minutes. So, you have to convert into same units. So, multiply by 3.2 by 2, you will get 6.4. So, lambda equal to 10. So, Poisson.Pm of 10 comma 6.4 will give you the answer for 0.0527. We will go to uniform distribution next. Suppose the amount of time it takes, you see that the amount of time it takes to assemble a plastic module ranges from 27 to 39 seconds, and the assembly time are uniformly distributed. Describe the distribution. What is the probability that a given assembly will take between 30 to 35? First we will develop that array. So, here u equal to np dot a range. There are two functions, one is range, another one is a range. A range means it is array function. If you type simply range, that is a list. So, 27 is the starting value, say 40 because it is n minus 1, 40 not 40, 39 will be the last value in the array, and the increment is by 1. We got this one. Now, this is our uniform distribution. Okay. Now, from scipy.stat import uniform. So, we have find out the mean of this distribution. So, for that purpose uniform.mean, LOC is the starting point 27, scale is how much? Plus 12. So, it is a 27 plus 12 is 39. So, that is the syntax for, so the mean is 33. Otherwise, in the uniform distribution, finding the mean is not a very complicated formula. Simply you have to find out the a plus b by 2. Okay. Then we will do the cumulative distribution, CDF, cumulative function. So, uniform.cdf np.a range 30, what the question was asked is 30 to 35. Okay. So, np dot array 30, because if it is a 35, we have to go up to 36, the increment is 1, starting point is 27, the scale is 12. So, this will give you the probability between 30 to 35. So, when you run this, so the probability of 30 is 0.25, 31 is 0.33, 32 is 0.41 and so on. Suppose we want between 30 and 35. For 30 the probability is 0.25, for 35 it is 0.66. So, if you subtract 0.66 minus 0.25, you will get the answer for that probability that the given assembly will take between 30 to 35 seconds. Okay. We will see one more problem. According to the National Association of Insurance Commissioners, the average annual cost of automobile insurance in the United States in a recent year was $691. Suppose the automobile insurance costs are uniformly distributed in the United States with an average of from $200 to $1,182. What is the standard deviation of this uniform distribution? So, we have to find out standard deviation of this distribution. Before that, we will check the mean. The mean is given $691. So, we will verify this uniform.mean, LOC starting point is 200, the difference is the scale is 982, that is 1182 minus $200, this one. So, it is yes, it is $691. If you want to know the standard deviation of the uniform distribution, because this formula is different, it is not simple standard deviation. So, uniform dot std LO is 200 comma scale is 982, you will get a standard deviation of 283.47. Okay. Next we will move to the normal distribution. Here also I have inserted a picture of normal distribution. You see that the picture is taken from this link, exclamation square bracket, that link. Okay. Okay. When you execute this, you will get a picture of probability distribution, that picture. First we will have to import a library norm that is imported from SciPy. So, from SciPy.stats import norm, that is the value mean comma standard deviation 68, 60.5, 2.5. Suppose if x equal to 68, the mean of that normal distribution is 65.5, standard deviation is 2.5, what is the probability? So, we will run that. First we have to run this also. Yes, the probability is 0.8413. If you want to x less than that value, suppose if you want to know cumulative distribution of x greater than value, you have to subtract from 1. Suppose if you want to know the value 68 and above, so already we know up to 68 this much value. So, the remaining area is, because we know the area of the normal distribution is 1. So, 1 minus the remaining, that value will give you the right side area. Suppose if you want to know the value between x1 and x2, for example, value 1 less than or equal to x less than or equal to value 2. So, it is a very simple print.norm.cdf, you find out the upper limit and the lower limit. Simply you type the lower limit, because the value ms already I have declared. Now, suppose the between 68 and 63, x value 68 and 63, if you want to know the area directly, is very simple, it will save a lot of our time. Suppose what is the probability of obtaining a score greater than 700 on a GMAT test that has mean 494 and standard deviation of 100. Assume GMAT score are normally distributed. There is another example. What is the probability of x greater than 700 when mean equal to 494 and standard deviation is 100. So, because we want to know x greater than or equal to 700, so we have to find out x equal to 700, then subtract from 1. So, print 1 minus norm.cdf 700, and the 494 comma 100 will give you the answer for this one. What is the probability that randomly drawing a score, so 550 or less? So, we have to read x value less than or equal to 550. So, 550 comma 494 comma 100 will be the answer. What is the probability of randomly obtaining a score between 300 to 600 from the GMAT examination? Actually, this problem is taken from Statistics for Management, Levin and Rubin. Okay, now you see that the upper limit is 600, lower limit is 300. Between 600 and 300, what is the probability? So, print norm.cdf 600 comma 494 comma 100 minus, this was upper limit, minus norm.cdf 300 minus 494 comma 100 is the lower limit. What is the probability of getting a score between 350 and 450 on the same GMAT exam? Okay, 450, 350, there is another example, but similar to previous one, it is this one. Now, we are going to do the reverse of that. Now, you see that so far we have to find the CDF, cumulative probability. Now, suppose the area is given. If the area is given, we want to know the x value. If it is a standard normal distribution, we want to know the z value, because the default function is the standard normal distribution, where the mean equal to 0, standard deviation 1. So, area under 0.95, the corresponding z value is 1.645. This value you can read it from the table the same way which I have explained in my theory lecture. Suppose if you want to know, most importantly here norm.ppf, that is a probability function. So, norm.ppf 1 minus 0.6772 will give you the left side area. So, we will see what is the corresponding left side is z value is, yeah, here we are going in the left hand side. So, the z value is minus 0.459. Now, we will see an example of hypergeometric distribution. The example says, suppose 18 major computer companies operate in the United States and that 12 are located in California's Silicon Valley. If 3 computer companies are selected randomly from their entire list, what is the probability that one or more of the selected companies are located in the Silicon Valley? What things you have to notice here is one or more. So, for that means we have to see what is the probability of getting one or more selected companies. So, from scipy.stats import hypergeom p value equal to hypergeom.sf. sf means survival function. So, here if it is 1 or more means that 1 minus 1. So, 0, 0 comma 18 represents the population size, 3 means we are choosing, that is the number of sample 3, 12 means the number of success in the population, that is a capital A, the same notation what you used in our theory. So, here the p value is 0.9754. We will see another example. A western city has 18 police officers eligible for promotion, 11 of 18 are Hispanic. Suppose only 5 of the police officers are chosen for promotion. If the officer chosen for promotion had been selected by chance alone, what is the probability that one or fewer of the 5 promoted officers would have been Hispanic? So, what we need to know here, one or fewer. So, here we have to find out the cumulative probability. So, the formula for finding the cumulative probability for hypergeometry function is the p value I am going to save in the name of p value equal to hypergeom.cdf 1. So, 18 represents the population size, 5 represents because choosing 5, 11 represents the number of success in the population. So, when you run this you are getting 0.04738. Now, we will go for next example on exponential distribution. We will take a sample problem. A manufacturing firm has involved in statistical quality control for several years. As part of the production process, parts are randomly selected and tested. From the records of these tests, it has been established that the defective part occur in a pattern that is a Poisson distributed on an average of 1.38 defects every 20 minutes during production runs. Use the information to determine the probability of less than 15 minutes will elapse between any 2 defects. Here you have to look at the 2 things in this problem. One is the mean of a Poisson distribution is given mu, and second thing is the between any 2 defects. No, when, as I told you in the theory itself, whenever the between 2 things you have to go for exponential distribution. Now, first we need to find the mean of a exponential distribution. So, the mean of a exponential distribution is 1 by mean of the Poisson distribution. So, here Poisson distribution mean is 1.38. So, the lambda we can call it as mu1, that is mu1 is for the mean of a exponential distribution, mu1 equal to 1 divided by 1.38. Okay. So, that value is this much. Okay. Suppose what was asked, probability that is less than 15 minutes. From scipy we have to import exponential function. So, we have to find out the cumulative probability, for that exponent.cdf. So, the 0.75 represents, because we got 0.75 by dividing 15 divided by 20, because that is the mean was in the Poisson distribution, mean was for 20 minutes. Now, the problem for the exponential distribution is asked for 15 minutes. So, we are dividing 15 by 20 so that the units are matching. So, we need to find out the cumulative function of exponential distribution. The lower limit of that x is 0, the upper limit is 0.75. So, exponent.cdf upper limit 0.75 comma lower limit and the lambda value. So, we will get the 0.644. Okay students, so far we have seen binomial distribution, how to use Python, then we have seen Poisson distribution, we have seen uniform distribution, we have seen normal distribution and exponential distribution and hypergeometric distribution also. So, we will continue in the next class with a new topic, that is on sampling and sampling distribution. Thank you.